I'm here today to talk about DevOps. As Brian said, I co-founded DORA. We are, I think, probably the longest running research program into DevOps. We've been going since the State of DevOps report in 2014, which was a Puppet production. Probably everyone is familiar with DevOps. Who came to see Nathan speak on Monday? Okay, so I'm just going to briefly recap some of this for people who weren't there. We define DevOps at Google as an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. So everyone's got their own definition. That's by design. This is what we think about how to define DevOps at Google. Take your own definition. That's totally fine. We're still learning how to get better at doing these things, how to get better at building and operating software systems. New technologies are coming out all the time, so there's no one way of doing it. In this program, we found out a way to measure software delivery performance, the impact of changing software delivery performance on organizational outcomes, and the factors that drive improved performance. So, how do we measure software delivery performance, and why is it important? We found that actually software delivery matters. We were told for a long time that it's not strategic to be able to deliver software faster and better, but actually we found it is. It improves not just commercial outcomes, such as profitability, productivity, and market share, it also impacts non-commercial goals that we're all familiar with in government, such as the ability to achieve organization and mission goals, the quality and quantity of products or services we can provide, our ability to deliver customer satisfaction and improved operating efficiency as well. So these capabilities matter. They matter to your organization or to your business. There's 4 things that we found are important in driving those organizational outcomes, which we call software delivery and operational performance. So 2 things to do with speed. Deployment frequency, how frequently you can deploy into production, and then lead time for changes, how long does it take you to go from writing code to getting that code out in production? And then 2 things that are concerned with stability. Change fail rate. When you push a change out to production, what percentage of the time do you have to roll back or remediate because something went wrong? And then time to restore service when something goes wrong in production, how long does it take you to actually fix that problem? What we find, and we found this consistently every year, there's no reason it should come out like this, but it always does. We do cluster analysis to take the responses to our surveys and group them into clusters in a way that's statistically valid. What we find every time is that our responses split into 3 or 4 groups. There's always an elite performing group or a high performing group that's able to deploy faster and achieve higher stability. And at the bottom, a low-performing group that deploys infrequently and has worse stability, and then 1 or 2 groups in between. And that's really amazing for me. Every time we run the stats, I kind of hold my breath, because we've been told for so long that speed and stability is a zero-sum game, that if you go faster, you're going to break things. And what we find is that that's not true. Actually, speed and stability are complementary. The best teams are able to go fast and produce higher stability and higher quality and have happier teams as well. And so that's what we're actually working towards. Not go faster and break things, but go faster, higher stability, higher quality, happier teams. You should be able to push out changes at any time, and it should be a complete non-event. And what we found since we wrote the book in 2010, Dave and I, is that this is possible anywhere. We have case studies from, again, government, from financial services, from any kind of organization you like, firmware. You can do this anywhere. It is hard. It takes time. It takes investment. It's actually a whole bunch of different practices. We found, I think there's probably like 13 things on this technical practices list that help drive this capability of making releases boring and being able to perform them whenever you want. Implementing those things not only drives better performance, it also drives cultural change. So, as Nathan said on Monday, you can't change the way you think to change the way you act. You have to change the way you act to change the way you think. Changing the way you behave is what changes culture. And so implementing these practices drives cultural change, which in turn drives performance. And then implementing these practices and achieving this capability also results in teams that are less burnt out, that have less pain deploying, and that have higher quality measured in terms of the amount of time people spend doing rework. Instead of this idea that we'll build something and then after it's built we'll test it and then we'll do the security analysis, that doesn't work. You can't take software that wasn't built to be secure or built to be performant and then once it's built, then fix those problems afterwards. You can't wave your magic wand and have the DevOps fairies come and make your insecure software secure. That's not something you can fix after the fact. You have to actually build that in. And so a lot of these practices are about giving developers really fast feedback from the beginning about the impact of what they're doing. And has this change introduced some security vulnerability? Has it made the system less performant? Have I introduced a defect? You want to get developers that information straight away so that they can make sure their software is always deployable from day one. Even if you wouldn't necessarily want users seeing that stuff, it's got to work from day one, and it's got to achieve all those different requirements that we care about. In order to do that, we need a lot of testing, and we need to be doing testing not after dev complete, we need to be doing testing all the time. So continuous testing is one of the key cornerstones of continuous delivery. That means having a lot of automated tests, testing that the system, that the individual methods and functions do what they're supposed to do, but also that we can actually run a user journey end to end, and that works in an automated way, testing performance and security and all those kinds of things in an automated way, and doing manual exploratory testing all the way through the software delivery lifecycle, not just at the dev complete point. We tie all that stuff together into what's called a deployment pipeline. A deployment pipeline means everything you need to reproduce the configuration of your production environment has to be in version control. I should be able to stand up a production environment or a production-like environment in a fully automated way using information from version control and be able to deploy my service to that environment in a fully automated way. That's what we're looking for. And then anytime I make a change to that system, we run automated tests. If those tests fail, we fix them straight away. Once we have a build that passes the automated tests, that goes downstream for maybe performance testing or security testing or other kinds of exploratory testing that we're doing all the time. And again, the moment we find a problem, we fix it straight away. Once we have builds that are deployable, we can do a push-button deploy into a staging or pre-prod environment, and then we can use exactly the same process that we've used for that to do deployments into production environments. That's because we have this capability of complete traceability from source control to production, and everything is automated. But that is extremely hard to do. It takes a lot of investment. It's expensive, but it gives you this amazing capability, which you care about, not just from the velocity point of view, but also it's critical for security. The same thing happened with Apache struts a few years ago, and it's exactly the same problem. They just didn't know which of their production systems were using that vulnerable version, and they had to do archaeology to work out which services were impacted and how to fix them. So we find in our research that actually high performers build security into software. They're not using a downstream process to validate security. They're conducting security reviews frequently. They complete changes rapidly. And they're running security tests as part of the deployment pipeline. And the job of InfoSec is not as a gatekeeper. It's to make it easy for development teams to do the right things by building tool chains and processes and making it easy for developers to get fast feedback and do the right thing. So building security in is a key capability that enables continuous delivery. You shouldn't try and do it all at once. And if you try and do it all at once, you'll probably fail. We actually investigated what are effective strategies for transforming your organization. And what we find actually is that a lot of the very popular ones are not, in fact, used by elite performers. So things like center of excellence. Not to say these things can't work, just to say that you've got to be really careful. If you create a center of excellence, for example, and you put all the excellent people in the center of excellence, who are all the people who are actually doing the work? They're the people that are not excellent. How good is that? How do you think people are going to feel about that? It's problematic. What we find actually works really well is not top-down, not bottom-up, but building community structures that involve everyone in the organization. So that means building communities of practice, doing grassroots stuff, experimenting with ideas, and then taking the things that don't work and talking about those. We tried this and it didn't work, here's why. Doing retrospectives and postmortems, and then taking the things that do work and then helping those organically move out through the organization. And I've got an example of how we did that at Google. Google did not do a lot of automated testing early on. I've been working in XP teams since around 2005 when I joined a company called ThoughtWorks. And I was brainwashed into it. I remember reading the XP book in 2001 and thinking, well, this can't possibly work, what a load of crap. And then joining a team in 2005 that was doing XP and getting brainwashed and then realizing this actually works. It's amazing. I never want to work any other way. But it wasn't, being told you have to have 80% test coverage from your unit tests. Like, that doesn't work. So Google did not have a testing culture. And the testing culture was built by a community of practice that had no official funding. And they basically did it in their 20% time. They did it in Google, assuming you're doing fine in your performance reviews, you get 20% of your time, or as we sometimes jokingly call it, 120% of your time, to work on things that you personally care about. And so there was a group of people that created what they call the testing grouplet. So it was a bunch of Google developers who really cared about testing and wanted to build a testing culture. Again, no budget, no official project to work on it. But what they did is they came up with all these ideas to help build the testing culture. One of them was called Testing on the Toilet, which is a monthly newsletter that they would print out and then paste on the back of all the toilet cubicles so that you could never escape from learning about testing. And if you go to a Google campus today, you can still see, in the restrooms, they have Testing on the Toilet newsletters still printed out every month. And so it was kind of thinking of ingenious ways to help get people excited about this and talk about it and start working in this way. And that is how we implemented Google's testing culture. And, now we have things like, I can't check in a change without writing tests for it. It won't pass code review. We have static detection to make sure that you have good coverage and stuff like that. But that doesn't work unless you have the culture in place. And the culture is created by people who are interested in it and infect other people and get other people excited about it and make it just the way that we work.